Okay, dear student, let us solve this problem. This is from chapter 16 of Beer and Johnson. Uh, s- so here and there is a flywheel over here. So this is a flywheel on which uh, a wire is wrapped, and the wire is attached to a mass M, and this mass M is released from the rest. And it has been asked that what would be the acceleration of block A, and what would be the speed of block A after it has moved by 1.5 meter. So here we have to apply Newton's second law, or momentum balance and angular momentum balance equations. So first of all, let me show the external forces and external moments applied to the body. So we can see that the external force is this one, which is m times g, and of course this flywheel, there will be rx and ry. So the two reaction forces are there. Now if I can draw the free body diagram of the two bodies separately and apply the valence equations. So first of all, let me draw the free body diagram of mass m. So here I can see that downward is mass times g and upward is tension T in the wire. Let's say that because of this, this block will get accelerated by acceleration A. So this is the free body diagram. So this is FBD, free body diagram, and this is kinetic diagram. Now I can apply net forces in y direction is equals to mass times acceleration, and this will provide me mg minus t is equals to mass times acceleration. So here we can see that there are two unknowns. One is the tension T and another is the acceleration A. Then let me draw the free body diagram of the flywheel. So this is the flywheel, and of course Rx and Ry. So again it's mg. So this Rx and Ry are not, do not allow it to move, and there is tension T downward. So this is again free body, and let me draw the kinetic diagram. So kinetic diagram would be alpha. This is FBD and this is kinetic diagram. Now I have to apply the Newton's second law in rotational motion, and that will provide me, let me call this as point A. So net movement about point A is equals to I times alpha, and this implies T times radius is equals to I times alpha. So here I get one equation, here I get another equation. The number of unknowns are T, alpha and A. So there are three unknowns and we have two equations. So directly we cannot solve it, but we have a relationship, kinetic relation, kinematic relationship between alpha and A. So we all know that acceleration can be written as r times alpha. So this is another equation which will provide you acceleration. Then there is another way to write the same. Let me copy this. Okay, so if I draw the free body diagram, this is mg and this is rx and ry. There are, and of course maybe capital mg you can write. However, okay, so let me write, if this point is a, so let me write sum of all the moments about point a, it is equals to h a naught, and which is I times alpha, sum of all the bodies, plus r cross, so this is sum over ri cross mi vi. This is what we got for this expression. We already know from for a system of rigid bodies, the momentum balance equation. Okay, so angular momentum balance, of course. So here there are two bodies. One body is this one, the flywheel, which does not have any linear acceleration. Sorry, let me correct this one. This is mi ai. So this does not have any linear acceleration and this does not have any rotational effect. Okay, so I can write I alpha plus r times m a. It is in the z direction, of course, so I am directly writing, and moment would be r times mg. Here the alpha is I is r times alpha plus r times ma is equals to r times mg. So here you have, this is r times a. So from here you can get easily what would be the a. Okay, another question, the second part of the question is the speed of block A after it has moved by 1.5 meter. So we here, since it is asked for speed, so let us apply the conservation of energy principle. So initially the energy would be, so let me write, okay. So what I have to do, I have to apply the conservation of energy. So initially there are two stages. Initially this is the body, it is at rest, omega is equals to 0 and v is equals to 0. After some time, when it has moved down, this has obtained some v and this is obtained some omega, and this fall is 1.5. let me call it as h. So So here the kinetic energy T1 would be half m v square plus half I omega square, and these both are 0, and v can be written as, let me put this as datum. So v1 can be written as mgh, and here T1 can be written as half m v square plus half I omega square T2, where half m v square plus half I v square by r square. R is the radius of the flywheel. So the unknowns over here is v. We can easily obtain. So the conservation of energy tells us T1 plus V1 is equals to T2 plus V2. Since there are no U1 to 2 non-conservative force, and it is equals to 0. So in this way, this equation will provide you the velocity. Thank you.